Hey guys, Mr. McKinney here, just going over how to find the second derivative, third derivative, and so on. It's pretty self-explanatory. You basically just keep taking the derivative. So if my original function was f of x equals 2x to the fifth minus 4x squared plus 5x plus the sine of x, and I want to find the second derivative, the third, and fourth derivatives, the first thing I need to do is find the first derivative, which is just the derivative. So the first derivative, or the derivative of f of x, f prime of x, I'd multiply. 5 times 2 is 10. Drop the exponent, so 10x to the fourth, minus 4 times 2 is 8. Drop the exponent, so it's just x to the first power. I do need that x, because x to the first is different from x to the 0. 1 times 5 is 5. Derivative of x to the first is just x to the 0, which is 1. Keep in mind this is a linear function with a slope of 5, so the derivative is 5. And then the derivative of sine is cosine. We're just going to memorize that one. All right, that was the first derivative, also just known as the derivative, or f prime of x. Now to find the second derivative, I just take the derivative of the derivative. So just do the same thing again. So the second derivative, and I'm going to put 2 primes there. Sorry about that. Not sure what that was. Let me try that again. So f double prime of x is how we would write the second derivative. 4 times 10 would be 40. Drop it down. It becomes x to the third. Minus 8, because 8x would be a linear with a slope of 8, or in this case negative 8, so negative 8x. Derivative of a constant is 0, so I don't need to write anything for that. And then the derivative of cosine is negative sine of x. So this should really just be minus sine of x. So to get the second derivative, just take the derivative of the first derivative. To get the third derivative, just keep going. So f triple prime of x would be 120. X squared, constant goes away. Derivative of sine is cosine, so I don't need to switch the sign here. It was negative, it stays negative. And then the fourth derivative, which you can do 4 primes, or you can do f with a little IV for Roman numerals, or you can do f with a little 4. You're not going to have a lot of problems where you actually have to write out this notation, but it would be 240x, 2 times 120 is 240, and then the minus cosine of x would turn into a plus sine of x, because the derivative would be negative sine of x, and we had a minus in front, so those two negatives together become the plus sign down here. So the second derivative, the third derivative, and then the fourth derivative. Just keep taking the derivative each time. All right, so we've got a few more practice problems. Feel free to hit pause on each slide, work it out for yourself, and then check your answers, or just watch me work it out. It's up to you. All right, find the second derivative. So to find the second derivative, I need to find the first derivative, and then take the derivative again. So the first derivative, which would be y prime, would be 6x squared minus 10x plus 5. Constant goes away. Second derivative would be 12x minus 10. Constant goes away. Asked for the second derivative. I see my answer choice there, and I'm done. All right, find the fourth derivative of this problem. Okay, first derivative, 7 times 6 would be 42. X to the fifth, 4 times 3 would be 12. X to the third, 3 times 2 would be 6. X to the first. Second derivative, 42 times 5 should be 210. X to the fourth minus 36 x squared plus 6. Also, I'm doing this in my head, so let's see how many mistakes I make. Third derivative, 210 times 4 should be 840. X to the third minus 72x. At this point, the constant goes away. And then the fourth derivative, 3 times 840. Looking at my answer choices, I'm going to assume that that's 2520. X squared minus 72. 72x turns into 72 when I take the derivative. So it looks like answer choice B. All right, last one. Find the 37th derivative of this equation. So hit pause, go ahead and figure it out. So first derivative would be 11 times 36 times x to the 35th minus 0.3 times 24 times x to the 23rd plus 43 times 15 times x to the 14th. Now, hopefully, as you guys started to do this, you realize that this problem is going to get incredibly obnoxious very quickly. But if the first derivative is already down to the 35th power, and each time we're dropping the exponent by 1, eventually, let's see, first derivative is going to be at the 35th power. Second derivative would be something x to the 34th power. Third derivative would be something x to the 33rd power, and so on. There's other stuff going on. But as this exponent drops, so 2 plus 34 is 36, 3 plus 33 is 36, the derivative and the power are always going to add up to 36. So when I do the 36th derivative, I'm going to be at x to the 0, which would be a constant. And then if I take the derivative of a constant, I'm going to be getting 0. So the answer would be 0. So again, to find the second, third, fourth, however many derivatives you want, just keep applying the same rules over and over again. Just add an extra prime each time you do it. All right, hope this helped.